Okay, hello again. I'm going to talk about our project. We have decided as a team that we are going to implement a four-motor four-wheel car. And we've decided to add functionalities to this car because without those functionalities, the car would be useless. So the first functionality we decided to add is the obstacles avoiding functionality. The obstacle avoiding functionality is to let the car move freely without colliding with any obstacle. We implemented this by adding a proximity sensor at the head of the car. This proximity sensor will sense if there is an object in front of it. So if there is an object in front of this sensor, it will send us a signal so we will know that we can't move forward through this path. So the car would basically rotate until it finds a free path. A free path is a path where there is no object in front of our sensor. The sensor wouldn't send a signal. So when the signal is 1, because it's active low, then there is a free path and the car will move on. The second functionality that we have is the door status functionality. And the door status functionality is a functionality where we make sure that the door of the car is closed. We do also this by a proximity sensor, because the proximity sensor would sense if there is a door closed or not by sending a signal. So if the door is closed, it will send us a signal of 0, active low, that there is a door and this door is closed, so there's no problem. But if the door is open, it would send us a signal of 1, which means that there is no object in front of it. So this means that the car cannot move when the door is open. The third functionality, and the last one, is the LDR, the light detection resistor. The light detection resistor would send a signal to the LED if the light goes off. So it's a very important one also for our car when it goes at night or something. So those are our three functionalities in our project, and my colleagues will complete discussing the project in more details. Thank you.
Hi, my name is Abdelrahman Kerdani. I'm 34-MET. Today we're going to talk about our embedded project. I'm assigned today to introduce the hardware details of our project. We have two IR sensors. Each one of them is used for a totally different functionality. An IR sensor is an electronic instrument which is used to sense characteristics of its surroundings by either emitting or detecting infrared radiation. The first one is used to detect if the car's door is closed or not. This works by sending a digital signal, either a 0 or a 1, with 1 meaning that the door is open and 0 means it is closed. If the signal is 1, all of the other functionalities will be disabled and the car will not move. If the signal is 0, the car will run normally. The second IR sensor is placed on the front side to detect obstacles that the car should avoid. The sensor calculates the distance to the first object it detects by calculating the time between the pulse emitted and the pulse received, knowing that of course the transmitter and receiver in our case are at the same location. After calculating the distance, we check if it is less than 50. If it is more, the car will proceed to move forward normally. If it is less, the car will reverse the motion of two of the DC motors connected to the tires for the car to move backwardly in a different curved line until the condition forces it to move forwardly again, meaning that there are no obstacles. This whole cycle keeps repeating for the car to proceed moving forward without hitting any obstacles.
My name is Waleed. I'm 34-MET. I will be explaining the hardware of our project. We have 4 DC motors connected to the 4 tires of the car. They are placed here under the car to control the motion of the car. To control the motion of the car and the rotation of the DC motors, we added a motor shield which is placed here above the Arduino. The motor shield allows controlling each DC motors independently, and they're connected each motor with the 2 wires here and here. We have total of 4 motors. The motor shield can operate up to 4 motors by connecting each positive and negative edge of each motor to the motor shield, which are here. Each pin of the motor shield are connected to the positive and negative. Initially 2 DC motors run forwardly and other 2 backwardly. These run forward and these 2 run backward to initiate the motion, causing the car to move forward in a straight line. As 2 of the 4 motors are placed in the opposite direction, if an obstacle is detected from here from the IR, the other 2 forwardly We'll change direction to simulate that go backwards and then move forward to avoid the obstacle. The last two components of the circuit are the LDR sensor, which if it detected light, this LED will have low signal, so it will not light. If there is no light, this will automatically be turned on.
My name is Ahmed Kamal and I'll be explaining the code.
We're going to include the AF motor.h, which is the library that helps us read from the motors. Here we're going to initialize our 4 motors, and then we're going to initialize our variables. Then first of all, we're going to read from the door's IR and put it in the variable called door input. And then we're going to read the LDR input and put it in the variable LDR input. Then we're going to check if the LDR input is less than 500, which means that that it's dark. Then the LED is going to turn up. Else, if there is light, the LED is going to turn off. Then we're going to check if the door is closed or not. If it is closed, we're gonna check. We're gonna read from the IR obstacle sensor to know if there is an obstacle or not. If there is no obstacle, we're gonna move forward. Else, if there is an obstacle, we're gonna move backward and turn. Else, if the door is open, the car is gonna stop. That's it, and thank you.